Jai Hind to all of you. I am Priyanka Sharma, Assistant Professor, EC Department. I am going to present my special complex topic lecture on special diodes. So, these special diodes basically we can study from the basic concept of the PN junction diode. So, this topic comes under the subject that is Fundamentals of Electronics Engineering. So, this code is BC101 and I am going to present the content regarding this topic. So, what is special purpose diode? We all know the basic fundamental of PN junction diode. What is PN junction diode? It is a combination of P-type and N-type semiconductor which comprises an electronic device which allows the current to flow in one direction and does not allow the current to flow in other direction. So, this can be used for as a different applications like switch, like rectifiers and for many other purposes. So, similar to this diode, we have another diodes also which can perform different special functions on the basis of their material, doping concentration. So, we can study different type of special diodes. So, these are the contents of my lecture. First, I will going to tell you about the special purpose diode LED, then photodiode, we will study about varactor diode and then lastly we will going to study about tunnel diode. So, first we will start with the special purpose diode, that is light emitting diode. In this light emitting diode is the diode which emits light when it is given with electric field. So, in normal PN junction diode we had studied when we apply the voltage it is going to flow the current, and as we increase the voltage it is going to increase the current after a cut in voltage. So, it allows the current to flow in forward bias direction. So, similar to that PN junction diode, in case of LED, when we apply the forward bias or apply the voltage, it will going to emit the light. So, with the very starting concept that LED is an optical semiconductor device which converts electrical energy into light energy. So, it emits the light, or we can say when we apply the supply or voltage, it will going to emit the light either in visible light range or invisible infrared light when it is forward bias, and that ranges can be given as the relation Eg is equals to h nu. So, what is this nu? H is Planck's constant, nu is C by lambda. So, and this Eg is energy gap. So, this energy gap will going to define the wavelength of the emission of light, and depending upon this emission wavelength we can categorize as visible length and infrared light. So, this is basically the symbol of light emitting diode. This is similar to PN junction diode, only the difference is arrow is pointing outward, that shows the light is emitting. So, in this if we see the working of LED, or we can see here when we apply the forward bias to the light emitting diode, then the free electrons in the conduction band recombines with the holes in the valence band and releases energy in the form of light. The construction is very similar to normal PN junction diode, only the difference is the material used here is gallium, phosphorus and arsenide for the construction of this diode. So, this difference is because that the silicon and germanium diodes do not emit light in the form of light, do not emit energy in the form of light, but in case of another type of material that is used in light emitting diode, that can be able to emit the energy in the form of light. So, when the light emitting diode is forward biased, the electrons from the N side will going to recombine with the holes in the P side. So, this represents the diagram which is showing the working of light emitting diode. In this we had seen here a PN junction LED is connected in forward bias. So in forward bias, when it is connected here, the holes from p type will going to recombine with the electrons in the n type. So as they recombines at the junction, this will going to release energy, and this released energy is emitted in the form of photons, or we can say light. So this is the process by which light emitting diode emits the light energy. So it is also written here, when free electrons reaches the junction or depletion region, some of the free electrons recombine with the holes in the p side, and free electrons recombine with the holes in the depletion layer. This leads to flow of the light. Now this recombination take place here in the basically when we can say free electrons in the conduction band releases energy in the form of light, and it is going to get into the valence band. Then only the combination will complete. The material used here, I already told you that for the light emitting diode is gallium arsenide with different doping concentration, or different impurities, different doping concentration and different impurity elements. So we have listed here with different materials. So in this, the material used here for the construction of LED that can be determined by the wavelength of the or the color of the emitting light depends on the forbidden gap or energy gap, which we had discussed here, and this is given by the formula, that is Eg equals to h nu. So this h nu is equals to Sc by lambda. This depends on different materials that is emitting different colors of light. We have the different combinations of gallium arsenide. Gallium arsenide LED emits red and infrared light color, and then gallium nitride LEDs emit bright blue light. Gallium phosphide LEDs emit red, yellow and green light. Aluminium gallium nitride emit ultraviolet light, and aluminium gallium phosphide LEDs emit green light. So these are the different materials with different impurity atoms going to emit different colors of light depending upon this wavelength. So as the energy band gap changes, as this energy band gap increases, wavelength is going to decrease, or if energy band gap is going to decrease, wavelength is going to increase. So this can be this band gap engineering can be used to generate different colors of light with different doping concentration with different impurity materials. So now next is, what are the different advantages of LED? So in this we had seen the LED is made from basically semiconducting device. So this is a very lightweight material. So the basic advantage is it has very lightweight, and the next is the brightness of light emitted by the LED depends on the current flow through the LED. Hence the brightness of LED can be easily controlled by varying the current. So that can be possible to operate the LEDs in a very low voltages. Now we can say also, because since it is a semiconducting material which can consume a very low amount of voltage, and especially it is made from gallium arsenide and or many other impurities which is very cheap and easily available, and also because of the semiconducting element, it is smaller in size, LEDs have longer lifetime, it operates very faster, and it can emit different colors of light by changing the different impurity concentration. Beside of these advantages, there are some disadvantages of LED also is there. LED needs more power to operate than normal PN junction diode, and the luminous efficiency of LED is very low. Now, what are the applications of LED? LEDs can be used, as you all know, in our houses also. We have different application: burglar alarms, calculators, picture phones, traffic signals, digital computers and multimeters, and many more applications. Now the next application is, or the next special purpose diode is varactor diode. So what is varactor? Varactor is basically made from the combination variable capacitor. Varactor, if we bifurcate is, this is called variable capacitor. Variable capacitor. So where represents the variable? That means we have a diode with variable capacitance. So this varactor diode can be used as varying the capacitance. So varactor diode is also a PN junction diode, but only in this case the difference is it has a minute property which can be used by varying the reverse voltage or forward bias voltage. And by changing this forward voltage and reverse voltage, we can make the diode as variable capacitor diode. It can also be called as varicap, tuning diode and variable reactance diode. The symbol of this varactor diode is, this is the diode and the capacitor symbol is put here. And the same configuration, this side is anode, positive terminal, this is cathode, negative terminal. This shows the parallel plates of capacitor. So the basic concept of capacitance comes from the depletion layer which we had observed in the PN junction diode. So this is a PN junction diode, this is P side, this is N side, and we have, this is P side and this is N side. This is the depletion layer, and in P side we have negative immobile ions and in N side we have positive immobile ions. So these two layers of immobile ions will create two plates, one is negative plate and one is positive plate. So this comprises the capacitance effect. This will going to build the capacitance effect in the diode, and this capacitance effect can be utilized to make this PN junction diode as variable capacitor diode. Variable capacitor diode. So now if we connect this PN junction diode in two bias conditions, one is forward bias and then another in reverse bias, then we can vary the capacitance. At this condition, when no biasing is given, at the zero bias voltage, this has a maximum capacitance. Or if we now apply the forward bias and reverse bias, we can get the different values of capacitance, and this can be related by the formula, that is CT. This can be related by the formula C equals to epsilon A divided by W. W is the depletion width. And first, if we make the diode forward bias, depletion width is going to decrease, and in this case capacitance equals to epsilon A divided by W. If it is going to decrease, then capacitance will going to increase. And the other case is reverse bias. In reverse bias, we know that depletion width W increases, and as the W increases, C equals to epsilon A by W. If this W is going to increase, capacitance is going to decrease. So in these two conditions, we had seen the different behavior of capacitance change with the changing potential barrier. So in this case, we can study here, or we can see here, the junction capacitance is basically inversely proportional to the width of depletion layer, and if width of depletion layer is less, the capacitance will be more, and vice versa. So if we need to increase the capacitance of a varactor diode, the reverse bias voltage will going to decrease and width of the depletion layer is going to decrease, so resulting with the higher capacitance. Similarly, we will going to increase the reverse bias voltage, the capacitance will going to decrease. So this will going to give you the changing nature of capacitance with the varying applied voltage. So by varying the applied voltage, we are going to vary the capacitance. So that's why it is called as varactor diode. So this can be related by this formula. We can also see here this relation कि capacitance is inversely proportional to the voltage applied. If voltage is going to increase, capacitance is going to decrease. So this can be very well shown with the help of this graph. In the reverse bias condition, if the reverse bias voltage is increasing with reverse voltage is increasing, capacitance, or we can say the depletion width is going to increase. If depletion width is going to increase, then capacitance epsilon A divided by W will going to decrease. So this is showing the graph at no bias condition, maximum capacitance is there. After this, capacitance is decreasing with the increasing reverse voltage. So this can be utilized in various applications. Varactor diode can be used in frequency multipliers. Varactor diode can be used in parametric amplifiers. Varactor diode can be used in voltage controlled oscillators. So these are the few applications of the varactor diode. Now after this, we are going to study the next special purpose diode, that is the photodiode. Photodiode is just inverse of LED, that is the light emitting diode. So in this case, we are going to study about the photodiode. It is again a different special purpose diode which is going to absorb the light energy and converts this into the electrical energy. So this also comes under the optical or optoelectronic device. So photodiode is specially designed to operate in reverse bias condition, or we can say it is based on the principle of, it is basically based on the principle of photoelectric effect. It is based on the principle of photoelectric effect. What is photoelectric effect? Basically, photoelectric effect is the process in which we can see when the light energy is fall on the material, it is going to produce the electrical current. So this is going to give you the photoelectric effect. So in photodiode also, this is basically made from p-n junction diode. Either it is made from silicon material, germanium, or this can be have a different response time also, and we will discuss about what is response time here. And this is the symbol of photodiode. In this, it is same as p-n junction diode. The light is falling to the device, so that's why arrow is inwards. So this is the symbol of photodiode. Now we are going to study about the various steps involved in photo detection process. How a photodiode is going to detect the light. So it is mainly consists of 3 steps. First is absorption of light. That means first light is going to absorb, and that leads to generation of the carriers. This light energy is absorbed by the material, and that light energy is going to break the covalent bonds, and that leads to generation of carriers. After this, the generated carriers will be transported, or that is called the transportation step. This generated carriers will be transmitted to the respective polarities of the field, opposite polarities. So that will leads to the gain of energy. So as the charges flow, that leads to flow of current. So this flow of current says the conversion of light energy into electrical energy. Third step is carrier collection. This carrier collection, that means the generation of photocurrent, will going to take place in the external circuitry. So that will shows the complete process is going to done. So in this process, with the very first step, that is the absorption process will take place, then transportation of charge will going to take place. After this, collection at the respective opposite polarity will going to take place, that leads to flow of external current. Now after this, we are going to see the working of photodiode. This works basically in reverse bias condition. Why? Because in reverse bias condition, as we apply the reverse bias, the depletion width is going to increase. So in depletion width, we have number of bonded covalent bonds. So if we are going to fall the light over the depletion layer, number of charge carriers generated will be more. So in reverse bias condition, this minority charge generated will recombine before they reach the junction. Or in this case, we can say initially when we apply no voltage or no light, we can say there will be no current flow take place. And when the external energy will be applied to this and light fall over this take place, that will going to break the covalent bond. That light is going to break the covalent bond, that leads to generation of charge carrier by breaking up of covalent bonds. And that breaking up of covalent bonds will going to supply the number of charges, and this will going to lead to flow of current. So this can be explained from this statements. When a photon of energy strikes the diode, it makes a couple of electron hole, and this mechanism will going to take place or called as inner photoelectric effect. Then in this case, holes will move towards, generated holes will move towards the anode and electrons will move towards the cathode. That leads to a current that called as photocurrent, and when no light is applied, the reverse bias photodiode will carry a very small reverse current due to the external voltage. Now if we going to fall the light, total current produced in the diode is sum of the dark current plus photocurrent. So the current which is flowing with no light condition is called as dark current, and the current which is flowing when the light fall over it is called photocurrent. So the total current is equals to the photocurrent plus dark current. So now after this is showing the working diagram. In this we are seeing here this PN junction diode is connected in reverse bias condition. This is the reverse bias condition, and the reverse bias condition diode, when we fall or incident the photons over it, this photons are incident over it, at the depletion layer, number of covalent bonds will going to generate, charges will going to generate, and this generated charge carriers will going to flow in the opposite poles. That leads to flow of current here. Now we can have a different types of photodiode. The basic concept is a photodiode has a very sensitive device. This photodiode sensitivity can be increased. Sensitivity can be increased or can be defined by sensitivity of the photodiode is defined by the minimum amount of light it can detect. Minimum amount of light it can detect. So normal PN photodiode will going to detect the light which is less sensitive as compared to another type of diode, that is called PIN diode and avalanche photodiode. Normal PN diode has the depletion width which is less, but in PIN diode we had increased this depletion width by inserting the intrinsic semiconductor. Intrinsic semiconductor is inserted between P type and N type. So the depletion width is going to increase here. And in case of avalanche photodiode, gain of electron and hole generation will increase. So in all these two cases, the sensitivity is more. That means a minimum amount of light is going to generate more number of charge carriers that will going to flow of high current, but in case of normal PN junction, for the same amount of light, the charge carrier generated is less. So among all these three photodiodes, PN junction diode and PIN photodiodes are most widely used. Now next is the limitations, or we can say disadvantages. Photodiode should be always operated in reverse bias conditions, and the applied reverse bias voltage should be low. It generates low noise. It has very high gain. It should have very high gain. It should have high response speed. It should have high sensitivity. It should be very less sensitive to temperature, otherwise the false detection will take place. It should have very low cost. It should be of smaller size, and it should be reliable up to a longer lifetime. These are the applications of photodiode. These had number of applications in compact displayers, smoke detectors, space applications. It can also be used in medical applications also, computed tomography, and we have applications in instruments to analyze samples. Photodiode can also be used for optical communication for the detection of light at the receiver end, and it can also be used in measuring extremely low light intensities. So this is my last topic of the lecture. Now the next topic, that is next special diode, that is the tunnel diode, we are going to cover up it in the next lectures. So Jai Hind to all of you.